All right.
Okay, so everybody, welcome to our meeting for today. You should be seeing the 7 holy steps of subnetting, which I did send out to the class, and I've also placed it in the chat. So anybody who's here now, if you need this link, it's right here in chat. So you can also just, if you wanted to, be totally brutal to yourself, you just type in this URL. But if you just go to my webpage or go to my YouTube page and search for 7 holy steps of subnetting, you will find this lecture from 2012. And this is actually from Exploration 1, which was 2 versions of curriculum ago. And quite honestly, it would not be a bad idea. There's several lectures on chapter 6 of Exploration 1. And in some ways, I do believe actually that Exploration 1, there are 2 versions ago, the curriculum does a better job of describing the curriculum than what is in our current Introduction to Networks version 7. So this, however, if you relate it to what we did last week, this is exactly what we did last week using the 7 holy steps to figure out the, let it join here. So we see here, this is the document. So first we talked about determine the number of needed subnets. And we discussed how that would be sometimes simply given to you. Sometimes it would be dependent upon the network itself. So as we look at the network, we know that every interface that's on a router will be on a different network. We then write out our host bits. Again, that becomes an optional step down the road, but we write our host bits. Determine the number of bits you must borrow to get the number of needed subnets, and that's our 2 to the n equals the number of usable subnets. So if you need 2 subnets, you'll borrow 1 bit. If you need 4, you'll borrow 2 bits, 8, so on and so forth. Turn on or set to 1s the number of bits you must borrow from step 3 and find the decimal value. That way you can then get your new mask in step 5 and then find our variable at the end. So like we've got here, here's an example of deciding we need 2 subnets. We go in, we turn on the 1. So there's 1 bit turned on because we only borrowed 1 bit. So that's 128. Our new mask becomes 255.255.128. And then our variable. Now, one of the things I want to make clear here is in the curriculum, they have a concept that they discuss, and they call it the magic, they call it the magic number. So they've even got a video on it down here on subnetting with the magic number. The magic number, folks, is just what I call the variable. So you'll notice here in this video, they borrowed 1 bit. And so the magic number is 128. And so the networks are being divided by a value of 128. So 0 to 127 would become the first subnet, and 128 to 255 would be the second subnet. Exactly what I'm doing here. Okay. So the exact same concept. So in mine, when I call it the variable, they call it the magic number. So just don't get confused by that. Now, the good news is mathematically, it all stays the same. So whenever you're borrowing from any octet, you can find your magic number by finding the last high order bit turned on in the subnet mask. Okay. And if you cross multiple different octets, remember that you may have a variable in more than one single octet. And we'll talk about that as we move forward. But before we go too far, I want to do this real quick. I want everybody to take these numbers right here, and I want you to convert these from binary to decimal and these from decimal to binary. So take about 5-6 minutes and do that real quickly. Can everybody see that? The numbers? Somebody put in chat or just let me know that you can see the numbers that are in the notepad here.
Yep.
You can see them. Okay.
Yeah, I'm good.
Okay. When you get the first one done, just raise your hand in chat, because I want to do, I don't know if I've actually got that set up. I ain't got that set up. We can raise our hand. What's the process here, folks? How would we convert this? Somebody want to tell me? All right, Caleb's finished. So
Addition.
the addition method. Okay, so Caleb, how would you convert this one, Caleb?
Well, I already know that the last 4 bits is 10. I know it's 128, so it's 138.
Yeah, you did it the fast way. But if you did it the long way, you'd say 128, 128 plus 0. I got to put plus in there.
Yeah.
Plus 0 in the 64 position, 0 in the 32, 0 in the 16, 8.
Yeah, 8.
And then 0, and then 2. Golly, I can't. 2, and then 0. And that equals 138. But you also knew that 1, 0, if you were to break this into nibbles, you know that 1, 0, 1, 0 is 10, and 1 and all zeros is 128. So you just said that's 138. Okay. You also know this automatically is going to be more than 128. And you also know it's going to be an even number. Okay. This one's real easy. What is it?
227. I can't remember.
225.
225.
Because if it's 1 and all zeros, you got 128. If it's 2 ones and all zeros, it's 192. If you got 1, 1, 1, 1, 1 and all zeros, it's 224 plus 1.
Yep.
So that's 225. The addition method would just be 128 plus 64 plus 32 plus 1. This one's slightly trickier, not too much, but it's basically 64 plus 32 plus what? 8, right?
Yeah.
Okay. And that would give us
104.
I believe that is correct. 104. I will show y'all a trick. Now, be aware, you're not going to have this on any of your tests, so you need to learn to do this on your own. But if you take your Windows calculator and set it to programmer, you can actually go in here, and it is possible to put in go binary 1 0 0 0 1 0 1 0, and it will tell you what the decimal value is. Okay, so you also can say, let's go back in here and clear this, and we go 1 1 1 0 0 0 0 1, and then you got 225. So there's a way to check these if you need to check them in your calculator. Now, what's the method for decimal to binary? Subtraction, right?
Yeah.
So we could take 135 and we say, can we subtract 128 from it? And the answer is yes. And what does that leave us? Leaves 7, right? I believe that is correct. So you can't get 0 from it. I mean, 64, can't get 32, can't get 16, can't get 8, but 4, 2, 1. Unless I'm mistaken, we can go ahead and go decimal 135 equals 1000011. So it's 128 plus 7 gives us 135. And then 215, what is it? Anybody finished it up yet? So it's okay to check your work with this calculator, but don't do your work with this calculator, because when you get on the real test and you're having to do conversions, you're not going to have a calculator. It is not available. So what did you get for 215?
I got 11010111.
110.
10111.
Okay. Let's test it. 215. Yep. 1101011. Now 63, I'm going to show you a trick on this one. Okay. If you had, if it was 010000, that is 64, right? Okay. 63 is 00 and then all ones. And that's typically true too. Like if it was 127, if you want to convert 127, it's 0, 1, 2, 3, 4, 5, 6, 7. So 63 would be 00 and then 1, 2, 3, 4, 5, 6. 31 would be, okay, and so on and so forth. So with 63, that should be correct. So we go 63. Yep. 0011 1111. Okay. All righty. So conversions you've got down. That's good. So we'll move on. Any questions on those? I just want to come back to it and make sure we're still okay there. Let's look at how they teach subnetting. Now, what they do first is they do exactly like I did last week and discuss with you. They talked already about the different classes of addresses a little bit further up in the chapter, but they come back to this idea of standard prefix lengths, and these are the /8, which is what we typically associated with what class of address. What is this? We saw this and had to say this was classful. What class of address would this be? You got three choices, A, B, or C.
A.
Class A. Class A's are those typically associated with a /8 prefix, okay, which means there's 1 octet for the network and 3 octets for the host. Class B are /16s, 2 octets for the network, 2 octets for the host. And then Class C's are 3 octets for the network and 1 octet for the host. All right. So when we look at octet or using creating subnets on an octet boundary, we can actually use, for instance, a /8 or the 1000 network, and we're going to say we're going to go all the way out and borrow 8 bits. Now, using my method, what you will notice here is that if you borrow 8 bits, okay, you have borrowed this number of bits, and you will notice that the variable in the second octet is 1, but there's no variable in the third and there's no variable in the fourth octet because you've only borrowed 8 bits. For this reason, the subnets are 10.0.0.1 to 10.0.255.255 right here. And once you roll the third and the fourth octet by the total possible value, you go and roll the second octet by the variable. In this case, the variable is 1. So what we really did when you borrow along this octet boundary is we took this class A. Okay, by the way, this would have been, in if we had been doing our typical, it would have been 10.0.0.0/8. Okay, so that's a class A. We borrowed 8 bits to get 10.0.0.0/16. Okay, and that created all of these subnets. By the way, it's 256 subnets of 64,536 hosts is what roughly ends up being. But now we've got all these different networks. We've got this one. We've got 10.1.0.0/16. We got 10.2.0.0/16. And that's what these networks are here. So these are our different networks. And you'll notice what we did is we took a class A Okay, so this was what would have been a class A. Oops. This is a class A. And by borrowing 8 bits, we've made it now to appear like it's a bunch of class B subnets, right? Because /16 is what we associate typically with a class B. Likewise, by the way, if we borrowed another 8 bits, guess what we could do? And this is one of the most commonly used ways of doing things. You've got 10.0.0.0/24. All right. You got 10.0.1.0/24, 10.0.2.0/24, so on and so forth, all the way down, believe it or not, to 10.255.255.0/24. And that is when you're going all the way down on a /24 with a class C. So we borrowed all the way down. You'll notice here's all of our subnets now. So we now got 65,000 subnets of 254 hosts per subnet. This is an extremely useful way of breaking this class A down to be used on our internal networks. You also will remember, if you've read the chapter, that the 10 network is a special kind of network. What is it? The 10 IP address is a special IP address. What kind is it?
It's a private.
It's a private. It's an RFC 1918 address, which is a private address, which is for internal use only. Cannot be routed over the internet. Cannot route over the internet. So in other words, you can use this inside your network all you want. This is what we do at Stanley. We take the 10 network, we subnet it all the way down to /24s and use that for our VLANs. Now we assign, what we end up doing is actually assigning a portion to each building. So that each building may be a /16, and then from inside of there, we expand it and hand out /24s. And that's just, again, the idea of subnetting a subnet. You'll notice we're still using the magic number. We're still going up here and saying, okay, we borrowed 8 bits. So if we borrow 8 bits, our magic number is 1 in the second octet. If we borrow 24 bits, we would be all the way down into here, and it's 1 in the third octet. And that's all we're doing here. You see how we're rolling the third octet by that variable all the way down through. Okay. So they're not making anything up. They're just using a different method. Another thing you can do, folks, you can very easily do this. Let's imagine that we've got this network, 10.0.0.0/8. Okay. We want to make, instead of having one major network, we want to make 2 subnets. Well, if we borrow 1 bit from right here, because remember, if we're using our 7 holy steps, we would say, okay, we need 2 subnets. That's step 1. We're going to write our host bits, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then we'd say, how many bits do we need to borrow to get 2 subnets? That would be 2 raised to the first power, which equals 2. So we're going to borrow 2 bits. Turn those on. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. I think I had a 9 there. 1, 2, 3, 4, 5, 6, 7, 8. And we end up with a new mask of 128.0.0.0, which is, which is actually our new mask of 255.128.0.0. And we got to go find our variable, our magic number. So we'll go up here and look and say, okay, what is our variable right here? And that variable would be, keep this on the page so you can see it. The variable would be what? Somebody tell me what it is. Remember, we go up here and we look at step 4, find the highest order bit turned on, and find the value at that position. So what is the value at the 2 to the 7th position.
128.
Correct. So the variable is 128. So we can now take this particular network and break it into 10.0.0.0 and another subnet, which is 10.128.0.0. And so we would have all the way out to 10.127.255.255. Likewise down here, the other side would be 10.128. 10.255.255.255. What's the first usable IP address in this subnet?
.0.0.1.
Yep, 10.0.0.1. What's the last usable? Yep, 10.127.255.254. First usable here would be 10.128.0.1. Last usable would be 10.255.255.254. And so what we've successfully done is we took this network, we borrowed 1 bit. Now, by the way, what would be the slash notation for these subnets here?
/9.
/9, correct. These are now /9s because we borrowed 1 bit and broke this one class A or 1/8 network into 2 subnets of /9. And all they're doing down here is borrowing 8 bits to break this into 256 possible subnets of 65,535 hosts, or borrowing 24 bits to get 65,000 possible subnets, 65,000 plus, of 254 hosts. Does anybody remember how you determine the number of hosts on a subnet? By the way, how many hosts would there be on each one of these subnets? Remember our formula? All we do is we look at the number of host bits that are left, and we say 2 to the h, 2 raised to the h power, which is the number of host bits, minus 2 equals number of hosts per subnet. So in our example here, borrowing 1 bit, we would have 2 raised to the 23rd power minus 2, which would equal, and I might have to do the math on this because I honestly, that's one I definitely can't tell you. 2 to the 23rd be 8,388,606 hosts per subnet, which is not very useful because, quite honestly, we're not going to have very many networks. When we start looking at items like this, we're not going to have that many networks that have 8 million hosts on it because we don't want 8 million hosts in a broadcast domain. We recommend typically a /24 for our broadcast domain. So no more than 254 hosts in a single broadcast domain. And that's why we typically use a /24 on most of our internet or gigabit Ethernet ports, or any port that's connected to a segment that supports host. And we use less than or greater than /24 if we're using something like a point-to-point. So we don't want large broadcast domains because, remember, with a switch, every time a broadcast comes in, it has to go out every port except for the one it came in on. So if you had 400 users like this on a broadcast domain, you're going to have a mess. You're going to have the possibility of a large number of users having to deal with broadcasts that are taking place. So it's better to break them down into 2 smaller networks by borrowing an additional number of bits. In this case, this would have been a class B that we borrowed 8 bits from to make it appear to be a class C. And using this /24, we now have networks that consist of 254 hosts. Okay. Questions about subnetting on an octet boundary. One thing I will tell you about these packet tracers is pay very, very close attention to what they're asking you to do. You must be very specific about how you do your subnetting, because they do require you to be very particular about your subnetting. If you're not exactly what they're asking for, you will not get credit for it in packet tracer, even though it could be correct, because there are different ways of doing subnetting. So if it says to use the first network as this portion, you have to use it as that portion. Otherwise, packet tracer will not give you credit. So let's take a peek here at /16s. So we had, let me go back up here real quick. We had earlier looking at a /24. So if you borrow subnetting a /24 network, so in other words, you've already got these 24 bits set, whatever happens to be. It could be a 192.168.12 number. It could be a, it could be anything that's already got a /24 notation. So for instance, if you were to take 10.0.0.0/24 and you were to subnet it, well, the only way you could subnet it is by borrowing up to 6 bits. Because remember, we always have to keep at least 2 bits. Sorry, I don't know. I can't keep the phone from ringing, but you'll notice if we borrow 1 bit, our magic number is 128. Borrow 2 bits, the magic number is 64, 32, 16, 8, and 4. We will never have more than /30 as far as subnets are concerned, because you must leave 2 host bits in order to have enough host bits to support the network address, the broadcast address, and 2 usable hosts. So /30 will be as far as you can ever subnet on an IPv4 network. And by the way, that's perfect for point-to-point links.
Hey, Kelly.
Yeah.
I had a question up here looking at this about the 2 to the 8.
Yep.
-2.
Yep.
Looking up here at the -25, you've got 5. What is that? 7 H bits.
Yep.
Let me make sure I'm doing this right.
2 to the 7 is 128. Because remember, our formula, here's our formula. Our formula is 2 to the number of host bits minus 2 equals number of hosts, number of usable hosts. Okay, so what you do is you take 2 and you say, I'm going to raise it to the number of host bits that are left. So 1, 2, 3, 4, 5, 6, 7. It's not the value there, it's the number of bits left. So you say 2 to the 7th power minus 2, which equals 126. Because it's 2 to the 7th power. When we're finding the number of hosts, we're not looking for a magic number. We're using the formula.
Yeah. Okay. So something about my math was off.
Because look at this right here. If you do 2 to the 6th, it's 64 minus 2, which is 62 usable hosts. 2 to the 5th is 32 minus 2. 2 to the 4th is 16 minus 2. 2 to the 3rd is 8 minus 2. 2 to the 2 is 4 minus 2, which is 2. Which is why you can't borrow anymore, because 2 to the 1st power is 2 minus 2 is 0. So you can't ever go past the /30 when we're subnetting. So don't get confused by it. That is a little confusing when you think about the difference between the magic number. So see, the magic number here is a 4. But when you go to do your host, you have to do 2 to the 2nd power minus 2.
Yeah. Okay.
Likewise, if you want to know how many subnets this is, it's 2 to the 6th power. Because you find the number of bits you borrowed. In this case, you had a /24 and you borrowed 6 bits. So you've got 2 to the 6th minus 2. Okay. Just tell you the number of subnets you've got there. All right, now if we look at a /16, you'll notice things aren't much different. We still have pretty much the same magic numbers. We're just moving them to a different octet. In this case, the magic number with a /17 is still 128, 192, 128, 64, 32, 16, 8, 4, 2. But in this case, because you've got more than just 8 host bits to work with, you can actually have a magic number of 1 in the third octet. And then you can cross this octet boundary, and notice how we're now going across the boundary, and that's where we'd have a variable in each one of our different octets. Thursday, I'm going to use the screen in the office to show you how to actually go across the octet boundary so that you're able to borrow from multiple octets. I showed one example of that last week, but I'll show some more on Thursday. So notice here, number of subnets created. For borrow 1 bit, it's 2. Borrow 2, it's 4. All the way down to, if you borrow up to 14 bits, it's 16,834. And if you were to borrow 16 bits, well, you couldn't borrow 16 bits. The most you could borrow here would be 14 bits because of the fact there's only 16 total host bits. And look what they do. All they do, folks, right here is with a /23, they find the variable, okay, which in this case would be 2, and that's what they roll it by. So 0, 0, 2, 4, all the way down. So the magic number is 2. You also notice something that anytime you look at subnets, and this will help you so that you won't make a mistake. Go back up here and show you this. In your subnets will always, well, I can't say that with class A, but with class C. The subnets will be, in a class C, it will always be even. We won't say that on these, but okay. 0, 2, 4, all the way down. In these others where you're borrowing outside of that, you can actually have odd numbers in the third octet. Look at this 1,000 subnets. Now, you would to create 1,000 subnets, you have to have a /8 prefix. You would borrow up to 10 bits. You go here. You've had 2 variables: the variable of 1 in the second octet, the variable of 64 in the third octet. And this is how you would roll it. You'd see it go through 64, 128, 192. As soon as you've rolled these through all possible permutations, these first 4 subnets, then you would go and roll the second octet by the variable, which is 1, and then they would repeat. And that's what I'll show you on Thursday when we cross the bit boundaries using my method of subnetting. But this just shows you there's going to be 2 variables. There's going to be a variable of 1 in the second octet and a variable of 64 in the third octet. And so that's what we do. We roll the third octet by 64. You'll notice this goes all the way through 255 because 192 to 255 is this subnet here, the 4th subnet. And then as soon as that third octet is rolled through all its possible permutations, then you roll the second octet and so on and so forth. So the next actual, in this particular instance here, I'll show you something that's interesting. The next subnet here would be 10.1.64.0/18, and then 10.1.128.0/18, and then 10.1.192. Excuse me, didn't get a 192 in there. 192.0/18. And then what would be next? We rolled the third octet by all the possible permutations, 0 to 255. So what would the next be? 10.2.0.0/18, and then 10.2.64.0, 10.2.128, 10.2.128.0/18, 10.2.192.0/18. And then now you say, well, we rolled the third octet from 0 all the way down to 255. So our next one would be 10.3.0.0/18, and so on and so forth until you have 1024 subnets. So once you get your range of subnets, it's actually pretty easy to extrapolate what the other ones will be, because they're going to just be based upon rolling it using the variables. Questions? I want you to watch all the videos in chapter 11. If you haven't already done so, please watch all the videos in chapter 11. Go back and watch my video on the 7 holy steps of subnetting. And we're going to come back together on Thursday, and I'll be in the office at the big screen, and we will talk about continued subnetting and making sure that everybody understands subnetting, because it's extremely important as far as a concept inside of Introduction to Networks. It's probably the single most important. It is the single most important concept in the entire thing. IP addressing and subnetting, without doubt. Any questions? Any questions at all?
I think I'm pretty okay on it. I'll probably be reviewing still though.
Well, like I said, any questions you have, you can email, you can bring them with you next Thursday, or this Thursday. It's not next Thursday, it's this Thursday. Bring them with you Thursday and we'll go over it, and we will we'll try our best to get you to become subnetting gurus. I will also tell you, quite honestly, if you have a coworker that's real good with subnetting and you just don't understand what I'm telling you, ask your coworker to explain it to you, because I've had many a times, and you know how this is. I've actually taught this in the classroom. Half the class would understand it, half the class wouldn't. I'd have another instructor come in that teach the exact same thing using the same method, and for some reason they would understand it. There's also different methods to do subnetting. For instance, my 7 holy steps of subnetting is one way, the magic number is another way. A lot of people use the magic number, but you'll really see from today's discussion that my method and the magic number method really aren't that different from one another. It's just the way you come about getting that magic number. I do it a little more in a programmatic way so that you see where it comes from.
Kelly, when we get tested on this, will we have, I guess you could say a lot of time, or is there a time limit? Because I'm getting it, I'm just slow, and that's probably, I guess, the more I do it, the better I'll become, and the quicker it'll come to me.
Now, as far as our time here in the class, you should have plenty of time in the test that you won't have to worry about it. On the CCNA exam, you will need to be able to recognize fairly quickly, subnetting and what it is.
Sure.
But yeah, the more you work with it, the easier it'll get. I mean, I think now, especially since we're just now getting introduced to it, this is something that you will work with from now till you quit working with Cisco. So I think as you move forward, you'll get faster and better at it.
Yeah, I mean, I think I get it. It's just, again, I'm a little slow at it, but again, it gets just because it's new, and probably the more
that's it. Yeah, it takes a good while, and I still screw it up. I mean, even though I've done it so much, there'll be times I'll make mistakes, and if I'm rolling something out in a production environment, I'm always gonna I may subnet it by hand, but I'm gonna put it in a subnet calculator to make sure too.
Okay.
And most people do in the real world, just to make sure they don't make a mistake. Okay, well, everybody, that's all I've got for today. We will then pick up on Thursday and continue our subnetting journey and see what we can learn.
All right.